page 12, and we're looking at measuring segments. We're going to start very simple with a little exploration, and then some definitions, and then go to the back, start simple practice problems, and then get to grade level practice problems that involve algebra. This is exactly the same concept as measuring angles from yesterday. It's just now it's a line segment. A lot of people find this easier because they understand segments better than angles. Okay, so if you look right here, this picture, it says use the diagram below to determine the distance between each set of locations. 1 unit is 1 mile. This is like, what's it called? The legend on a map. Isn't that what it's called? Man, that's a long time ago. I've not used that vocab in a word in a while. I think it was called a legend, which lets you know, like, this symbol means a house, or this symbol means a state park, or whatever. And then it would give you the scale of the map, because the map clearly cannot represent the true distance between cities. They have to scale it down so it'll fit on the map and you can hold it in your hand. If from the house to, say, the campsite, from 0 to 6, and it says 1 unit is 1 mile, I want you right now to, over here to the right, write how many miles the campsite is from the house. There's not a lot of thinking involved here. There's no trick, okay? It's just, can you interpret 1 unit to 1 mile and then trust yourself to be right? So write it down. Try it with this one and this one as well. Notice this is saying, like, if this started at 1 and this runs to 12, they want the distance between. If this started at -4 and runs to 1, they want the distance between. Okay? So take a second, answer that. Okay. How far is the campsite from the house? Somebody blurt it out. How many miles? 6. Right? From 0 to 6 is a distance of 6 units, and it says 1 unit is 1 mile. All right. What about the bicyclist to the swimmer? We're measuring the distance between. 11. And how'd you get that? Yeah, so if this person's at, we'll say mile marker 1, and this person's at mile marker 12, if we're measuring the distance between from here to here, then it's 11 miles between the two people. Now the next one was not necessarily more challenging, but just now notice it says -4 up to 1. So what's the distance between them? Do what? 5 miles. Notice -4, if you need to see it, that'd be -3, -2, -1, 0, 1. And then you can see that it's 5 units, so it's 5 miles. We're not going to worry about these questions right here. We're just going to move on. That was just to kind of wrap your mind around the concept of measuring between two numbers on a given number line. Now let's look at actual definitions. But you know what? Don't highlight distance. If you already did, no big deal. Don't highlight distance. We're going to highlight the vocab words when we get to the bottom, congruent segments and segment bisector. Distance is the absolute value of the difference between points. The absolute value of the difference between points. Distance is always positive. Always positive. Okay, the next section, naming versus segment length. You see this segment right here? Clearly a segment, has a start and a stop. We already know how to name it. So come over here where it says name. I want you to name this segment two different ways right here. Show me the two different ways to name that. We practiced it 2 days ago. If you need a refresher, you can look at page 10. You're naming this segment. What'd you get for one name? AB. And what's the other? Yep. There's only two options there. Now, there's a difference between naming the segment and then talking about how long the segment is. So you'll notice there's nothing right here to tell me the length of this segment. We're going to go ahead and call it an algebraic expression. I'm going to write x plus 4. And it's hovering right next to it. X plus 4 hovering next to it is representing the length of it. You don't know what x is, but you do know that once you found x, all you would have to do is add 4, and then you have the length of the segment AB. So the length of AB is equal to x plus 4. So the name of it is AB. The length of it is x plus 4. So there's a difference between those two concepts. And now if you look at this little number line right here, it says, number 1, RT equals what? Number 2, VR equals what? Number 3, VT equals what? We're going to put a segment line, a segment notation above that. They're saying if you measure from R to T, so R to T, it's asking what is the distance, the length of segment R to T. Well, how would you find it? This is just like what we did at the top. Yeah, you're just going to subtract. Or you can count. If you're a counting type of person, you could count. Or you could say, well, this was at 7, and it goes to 2, so there's a length of what? 5. All right, now do V to R. So V to R, and then do V to T. We'll do V to T right here. So do those two real quick. What'd you get for VR? V to R is 11. You were at -4, that's 4 units to 0, and then from 0 to R is 7, so 4, you could do it one way of 4 plus 7, or you could do 7 back to 0 and then to -4. V to T. Did you get 6? All right, look at the bottom. Here's the new stuff. What is congruent? That sounded like 2 different ones. Everybody good? What's congruent segments? Let's highlight congruent segments. Let's highlight segment bisector. What did we learn congruent means yesterday? Equal. Congruent means they're equal. They're copies. Same thing. So if we're talking about segments, what do you think it means? Congruent segments would be what? Same length. Segments that are the same length. That's exactly the definition. Segments that have the same length. So we have 2 segments drawn right to this to the side. You cannot just assume they're equal. It does look like they're equal. You can't assume that. You would need to know that they are equal. If they were equal, you would have congruent marks on it. I tend to slant my congruent marks sometimes, or tick marks. Sometimes I slant them. It doesn't matter, or you can do them up and down. But that little mark right there, that little mark means equal. Just like those arcs that we drew yesterday in the angles that were equal. So if I wanted to talk about those segments as congruent, I would say that HI, segment HI, is congruent to segment JK. And that's what it would look like. That's what it would read. Okay, yesterday we learned what a bisector is. What we say was the simple definition for bisect. Cut in half. What do you think a segment bisector means? Segment cut in half. It's exactly like angle bisector, angle cut in half, segment bisector, segment cut in half. So let's write the definition. Now, it doesn't necessarily have to be a segment. You could have, no, you can't have a line cut in half because a line keeps going. So yeah, it is a segment. So a segment a segment that is cut in half by another segment, and then I put in parentheses or ray or line, because the piece that actually cuts it in half doesn't have to be it could be a line. In this picture, it's a line. It could be a ray. It could be a segment over a segment. What matters is this initial segment WY has just been cut in half by this line XZ. If it's cut in half, you would need to go to the picture and take notes on the picture. Sometimes you'll draw 2 tick marks. If you have a picture and you've already got 1 tick mark drawn, you can draw 2. But this means that WX is now congruent to XY, is what that means. one doing the bisecting is line XZ. So technically, line XZ is the segment bisector of WY, cutting it into two equal parts, showing that WX is congruent to XY. All right, let's go to practice problems. So at this point, if you would, I'm going to give you a 2-minute brain break. If you'll take your 2-minute brain break, and you're going to go exchange for a calculator. Okay, let's start out with the practice problems that are just numbers. If you go up to numbers 4 through 6, these questions have no algebraic expressions. They're very simple. This is the shallow end of the pool. If you would, take a second and try these. You are finding the length of segment CD. Number 4 does not involve any computations. What is your clue on the picture to help me answer the question? What's your clue? Like there's some mark that lets me know, hey, this is your answer. Do what? It is 12. And how do you know that though? Like what's the mark? What did your eyes look at and say to yourself, okay, the answer is 12? Right here, what's this? What's this little mark mean? There you go. That little congruent mark, very simple. It's easy to overlook. You almost think of it as a ruler mark. It's not a ruler mark. It's a, hey, this is congruent to this. So that tells me, hey, it's 12. All right. Coming over to number 5 is asking for the length of LM. Then it's asking for the length of LP. Take a second and try it. Be a problem solver, meaning you're trying it, you're looking at it, you're analyzing the situation and trying to decide, what do I know, what do I need to fill in, and what is the answer. All right, in the picture, what do I know already? I know the two sides are congruent. I have this mark here and here to let me know LM is equal to MP. What else do I know in the picture? There's a 7 underneath the congruent mark right here. This 7, because it's hovering in the middle over here, represents M to P. So if M to P is 7, then what's L to M? Also 7. And if this is also 7, it helps to label it because now the question is what's L to P, which would be 14. All right, y'all try 6. Be a problem solver. Don't wait for the answer to go on the board. Try it. It's okay if you end up getting it wrong. That's okay. Learn from the process of getting it wrong. Yes, you do come to decimals. It's okay. You do get decimals here. But they're pretty. All right, let's try it. What do you know? Remember the phrase, go to what you know. What do I know in the picture? What are some clues? I've got congruent marks once again. So I've got this big long segment, and then I have it's in 2 equal parts. What's another clue? And 37 describes what? Notice that you have this right here to let you know that the 37 means from X all the way to Z. Then look at what it's asking you to find. It wants X to Y and Y to Z. Well, x to y is what portion of the segment? X to y is what portion of the segment? Is it the whole thing? It's what? Half. You know it's half because of the congruent marks, right? So I get the number to represent from x to y by simply doing what with the 37? Dividing it by 2. What is it, 18.5? If this is 18.5, it helps to label your picture. What's y to z? Also 18.5. Okay, so that's the shallow end of the pool. Now let's take those exact same concepts, same thing. The math doesn't change, just the complexity of it changes. These are now algebraic expressions instead of just plain old numbers. Well, there's only two scenarios. Either the two things are equal, or, like over here, part plus part equaled whole. So those are your only two scenarios. So let's look at number 7. It says find the length of DE. Well, in order to find the length of DE, I need to know what x is, right? So this is the goal. What's the length of DE? Well, I need to find x first. What are they giving me in the picture to work with? What do I know? I know 5x plus 9 represents the length of DE, right? So I could come over here and say, okay, DE is 5x plus 9, but I don't know what x is, so I can't finish that part yet. I've got to set something up to get x. I'm going to set up an equation. We talked about, there's two scenarios so far that we've learned. It's either something equals something, or it's part plus part equals whole. What's the scenario here? What's an indicator in the picture to let me know the relationship between those congruent marks, y'all? Look at these congruent marks. It's saying, hey, this is equal to this. What scenario is that over here? The top one or the bottom one? The top one. There you go. Set it up. So you got one equals the other. I'm going to try to make this fancy, and I'm going to put, that we just said we got one equals the other. And now, of course, you would fill that in. So 5x plus 9 equals 3x plus 17. Now you have a multi-step equation like what we practiced last week, and you would solve it. Solve it for x. Solve that multi-step equation. You should come to x equals 4. Confirm you can get there. When you get x equals 4, what do you do with it? Yeah, you got to plug it in, which is why this little thing is helpful over here, because it lets me know, hey, your work done. You got to do something with the 4, because the goal was the length of DE. Did you get 29? Get 29? If you struggled to get 4, let me give you a refresher. So I take the 3x that's positive, subtract it over here. Then I would take the 9 that's positive and subtract it here. You may end up with 2x equals 8, and then I divide by 2 and get 4. All right, go to number 8. It says if ray JL bisects segment IK, and JK is 9x minus 20, and IJ is at 6x minus 11, find the length of IK. Okay, that's a lot. When you read it, you probably get confused. Go back to what I said yesterday. Take notes on your picture. Go to your picture and fill in all the info they just gave you. Look for key words like bisects to tell you something has just been, cut in half. And then find it and mark the pieces, the 2 half pieces, okay? So everybody should be taking notes on their picture for number 8, and then I'm going to put it on the board and we'll compare answers. All right, so taking notes, it says JL bisects IK. So IK is the one that just got cut in half. I'm going to do 2 tick marks because it kind of makes it, I don't know. 1 tick mark kind of makes me think of a ruler. 2 makes me think of congruent marks. Then it says JK is 9x minus 20. I'm going to label that there. And it says IJ is 6x minus 11. I'm going to label that there. And then it asks for the length of IK. So I'm going to do something very similar to number 6. I'm going to draw a line from here to here and put a question mark to let me know, okay, the goal is the whole thing. I all the way to K. That's the goal. Now I'm going to look at my picture and I'm going to think of what Ms. Holcombe has said about we only have 2 scenarios so far. We have part plus part equals whole, or we have 2 things are equal. When you first look at this, since we're trying to find the whole thing, you might think it's part plus part equals whole. But if I set that up, do I actually know the whole thing? No, I don't. So I would end up setting it up equal to question mark, and that would not get me anywhere. So what technique would we use here to get x? What technique would we use? Is it something equals something, or is it part plus part equals whole? Yeah, there's 2 things equal to each other. Something equals something. What are the 2 things that have to be equal? What 2 things must be equal? IJ and JK, which is why we have these marks here to help us to recognize 6x minus 11 has to equal 9x minus 20, right? Solve that. Confirm that you can get to 3. Make sure you can get to 3. I should be able to tell you the answer for x, but you still do the work to get there, okay? When you get to 3, remember the goal was to find IK. So what would you do with the 3? Yeah, plug it in to which ones? The goal's IK. Which one would I plug it into? The whole thing, or you could plug it into one of them and then do what with it? Add them up? Yeah, multiply it by 2. you get 14 for IK? Yes. Are there any questions so far? Or any confusion? Which brings us to the last part. We're going to highlight this. It is the segment addition postulate, which is exactly like the angle addition postulate. It's part plus part equals whole. So with a segment, in this case, name one part of the segment. Name a piece of it. AB. All right. AB added to other part, BC, equals, now name the whole thing. AC. A to C. So we're going to use that concept down here with these problems. We've got two with just numbers, and then we've got three that are grade level with algebra. So look at number 9. It says to find the length of GK. So G to K. What is it? 23. Right? So, you're good. Was that water?
Yes.
Okay. It's the whole thing, right? So 8 is one part, and 15 is the other part. So you get 23. All right, go to 10. Ten says to find the length of TV. Has an X right here. So I'm going to just highlight this and put a question mark above it. So that's my goal. Two ways to do this. One way is part plus part equals whole. So if you're a systematic person, one part's X, the other part's 31. What's the whole thing? 42. And then you would solve for X. Or if you understand the concept of, I know the whole thing, and I know one part, I'm just missing the other, you could use what instead? Subtraction, which is something, we're going to call it the subtraction method, I guess, because it's going to come up a lot, and you're going to find that it actually makes life easier. Go to the whole thing, subtract off what you know, you'll be left with what you need, okay? Did you get 11? All right, now let's go to the last 3. Same exact concept as 9 and 10. Same thing, same steps, same process, same setup. The only difference is the complexity is now an algebraic expression instead of just numbers. But the math doesn't change, so don't get lost in the algebra. Number 10 gives us a bunch of info and then a blank picture. What am I going to tell you to do? Fill it in. Fill your picture in. Take notes on your picture right now. Take notes on your picture. So O to M is 15x plus 7. M to L is 4x minus 9. And O to always draw that when it's the whole thing, it helps you, is 36. Then it says find x. Okay, we talked about this. We only have two techniques. It's either two things equal or part plus part equals whole. What am I using here? Yep, you're going to add the two parts together to equal the whole thing. And that's your equation. And you should come to 2. Make sure you can get to 2. Does anyone need me to work how to get to 2? No big deal if so, just kind of give me that look. Alright, let's go to 11. Once again, lots of info, blank picture. What am I going to tell you to do? Fill it in. Take notes on your picture. We have SP, we have PU, and then of course we have S to U. What's set up? Two things equal or part whole? It's another part whole. It only asks for x, you should come to 3. Make sure you can get to 3. Number 12, once again, lots of info, blank picture. Take notes on the picture and it helps you to know how to set it up. Now this time the whole thing is an algebraic expression, but that doesn't change the setup. Don't let the complexity of the problem make you forget how to do it. It's the same concepts that we've already practiced. It's either two things equal or a part whole. In this case, it's another part whole. It's just one of the parts is a number and the whole is an algebraic expression. It doesn't matter, it's still an equation. So you've got part plus part equals whole. If you label your picture, you'll never mess up what's a part and what's a whole. You'll never mess it up if you label your picture. Now this doesn't say just stop at X. It says to find AB, which is from here to here. So what do I have to do with X when I'm done? You got to plug it in. You should come to X equals 1. And then, of course, you need to find AB.